All right, let's do a quick review of the whole unit. Wow, the end of the unit. So we do have our unit test this week. Okay, let's take a look. 53 to 68. So let's take a look at 53. State if the polygons are similar. There's two things that in order for polygons to be similar, two things need to happen. First thing, the angles of one polygon have to be the same angles on the other. So I'm taking a look at my angles. And I'm like, oh yeah, they look the same. You know, the angles on the small figured are equal to the angles on the big figured. Okay, so first criteria is met. Second criteria is that the sides have to be proportional. Okay, so in the small figured, my numbers are 4, 5.6, and 8. There's another 5.6, but I'm only gonna write 5.6 once. All right, I'm comparing three numbers, so let me write them all out. 4, 5.6, and 8. Notice I'm going to make three fractions. Notice I wrote my numbers from small to large. Okay, 4, 5.6, and 8. On the other figure, my numbers that I have are 7, 12.7, and 16. So I'm going to write them all down. 7, 12.7, and 16. Okay, there's two ways how I can check if the sides are proportional. One, I can simplify my fractions. They should simplify to the same thing, all of them. They should all simplify to the same thing. Another thing I can do is check two fractions at the time. I can cross multiply, right? If I wanted to check, for example, the first two fractions, I could cross multiply and I should get the same result. So 4 times 12.7 should equal 7 times 5.6. So I check the first two, and then I check the last two. I cross multiplied. But in my case, actually, I'm going to simplify. I see the last fraction is easy to simplify. If 8 over 16, I'm going to simplify that as 1 over 2. Right? I divided each number by 8. Remember, in order for us to simplify the fraction, we have to divide the top and bottom by the same thing. So I divided by 8. So it simplifies to 1/2. I don't want to deal with the middle fraction right now. I don't want to deal with decimals. Let me take a look at the first fraction, 4 over 7. Um, there's nothing I can do. So that simplifies to 4 over 7. Before I continue, the two fractions that I have, so I don't want to work with the middle fraction unless I have to. I see the two fractions that I have, 4 over 7, 1/2, are not the same fraction. So I already have two fractions that did not simplify to the same thing. Therefore, my polygons are not similar. Remember I said in order for polygons to be similar, two criteria. The angles have to be equal, which they are, so I'm good. The second criteria, all the sides have to be proportional. One way I check if they're proportional is I make my fractions and I simplify. It then should all simplify to the same thing. That didn't happen, so not similar. Let's move on to question 54. Solve for x. The polygon in each pair are similar. Okay, so now we are told these polygons are similar. So I know the angles are equal, and I also know the sides are proportional. From one figure, I only need two numbers per figure. I might have more than two, but I only need two. From one figure, I'm obviously going to use the one that has x because I'm solving for x. And I know 2x is corresponding with 18. I'm also going to use 14, and I know 14 is corresponding with 21. Notice how I have a polygon where I circle the measurements, and I have the other one where I underline the measurements. All right, from the small figure, I'm going to use the values 2x and 14. I made a fraction out of them. Now I know 2x is corresponding with 18, and I know 14 is corresponding with 21. So 2x is on top. So on top of my other fraction, I'm going to put an 18. And over 21. And then I'm just going to cross multiply, right? I can simplify my fractions if I need to. I don't have to. I'm just going to cross multiply it in my case. Let's see. Let me change this to blue. So if I go this way, 2x times 21, that gives me 42x. And this other way, 18 times 14, use a calculator if you need to. 18 times 14 is equal to 252. All right, to get the x by itself, let me divide by 42 on both sides. So I get x by itself. 252 divided by 42 is 6. So I have that x is equal to 6. When you type in your answer, just type in the number 6. You don't have to type in x equals. So just 6. X is equal to 6. Let's take a look at number 55. State if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. I know this one was giving you a little bit of hard time when we were doing the homework. Let me remind you of the 3 rules that we can use. Okay, when we're looking if they are similar, I can use side, side, side. There's 3 rules that I can use. So side, side, side is one of them. Side, angle, side. And the last one is angle, angle. If I'm using sides, make sure the sides are proportional. So comparing your triangles, make sure they are proportional. If you're using angles, make sure the angles are equal. All right, I see the first one, to be honest, the first one I tried is side, side, side. If there's 3 sides of a triangle, cool, I just go for that. But looking at this one, there is a small triangle. I'm looking at this small triangle right here. I only have the measurements 9 and 11. I don't have all 3. So let me see, I have the numbers 9 and 11. Now I know 9 is corresponding with 18 and 11 is corresponding with 22. Some of you guys might be wondering, Mr. Leon, so how do I know if it's 9 and 11 on the top? Or what if I go 9 over 11 is equal to 18 over 22? What if I do the 9 and 11 as a fraction and then 18 and 22? To be honest, it really doesn't matter because whichever method you use, notice how if I go here on my top fraction, I'm going to multiply 9 times 22. Isn't that what I do here? 9 times 22. On my other case, I'm going to go 11 times 18. Isn't that what you do here? Okay, so once again, it doesn't matter. All right, so let me erase this real quick. I only need to do it once, right? So I'm going to just have it here. So as you guys saw it, I can cross multiply 9 times 22, 18 times 11. If I get the same result, then these 2 sides are proportional. 9 times 22, when I multiply this way, 9 times 22 is 198. This other way, 18 times 11 is also 198. If you would have simplified your fractions, the fractions would have simplified to 1 over 2, both of them. Okay, so I know my sides are proportional, right? I just check if the sides are proportional. Okay, so they are. I'm going to continue. Okay, so for sure, I don't have side, 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 right? I don't have 3 sides. Angles. It would be nice if I had an angle marked. But let me take a look at angle D. When you think about it, angle D from the small triangle, it's equal to angle D from the big triangle. Look, I highlighted my two triangles, one in red, one in green. Notice how angle D from the small triangle is equal to angle D from the big triangle, right? It's the same corner. I don't need to know the measurement. It is equal. So let me mark angle D. Let's just say angle D is given. So I'm going to use side angle side, two sides and the included angle. Now the order of the letters matter. Notice that here it says DEF, because I'm saying it is similar, I'm going to complete my similarity statement. DEF is similar to, okay, so the triangle. So DEF is the big triangle. So I'm going to complete it as DUV to begin with. I'm not quite done yet. The order matters. So DUV. If we write the three letters in a different order, like DVU, that's wrong. Order matters. So DUV, so triangle DEF is going to be similar to DUV. So triangle DUV by, now we had to state which rule did we use. And we, as I said earlier, we're going to use side angle side. So I completed the statement. When I complete a statement, it has to have a triangle, so DUV, and it has to have the rule. Which rule did we use? Okay. Now let's take a look at number 56. Find the missing length. The triangles in each pair are similar. Okay, so I see the question mark. I'm going to change the question mark with an X, right? We learned back in Algebra 1 that when we don't know the value of something, we just call it X. So I'm going to call that X. So from the big triangle, and when I say big triangle, I'm talking about QSR, the triangle QSR. From that triangle, I'm only going to use two measurements. I'm going to use X because I need to solve for X. And I know X is corresponding with 44 from the small triangle. And I can use from the big triangle either 132 or 154. I'm going to choose 132 just because it's smaller. And 132 is corresponding with 48. So the two measurements that I circle, I'm going to say X over 132 equals 44 over 48. Now we can simplify. I will recommend simplifying. 44 and 48, we could divide each by 4, right? So it becomes 11 over 12, a little bit smaller. At the same time, sideways, 132 and 48, we can simplify. I know we're going to cross multiply. We're going to multiply this way. So that's the only way we cannot simplify. So 44 with 132, we cannot simplify. But 132 with 48, yeah, we could divide each by 12. Now, if you don't simplify, let me not simplify. We're going to use a calculator. So X times 48 gives me 48X. 132 times 44 gives me 5,808. When I divide both sides by 48, it's going to give me that X is equal to 121. I was dealing with big numbers because we have access to calculators. Now, you don't want to deal with big numbers. Simplify before you multiply. Take a look at number 57. Solve for X, the triangles in each pair are similar. Okay, so pretty much kind of like question number 56, the one we just worked right now. So I'm going to say from the big triangle, and when I say big triangle, I'm talking about PQR. I'm going to use the measurements 25x minus 6, and that's corresponding with 26. I'm also going to use 143, which is corresponding with 22. The two measurements that I circle, let me make a fraction out of those. 25x minus 6 over 143 equals, okay, 25x minus 6 is corresponding with 26. 143 is corresponding with 22. Okay, so again, we can just cross multiply, deal with big numbers, or we can simplify before it. This case, I'm actually going to simplify. I'm going to simplify a little. 143 and 22. Remember, the way we multiply is the only way we cannot simplify. 143 and 22, let me divide each by 11. Okay, so I'm going to divide each by 11. So that's going to give me 13 and 2. We could probably simplify the fraction 26 over 2, divide each by 2, but I think the numbers are not that big anymore, so I'm just going to cross multiply it already. When I go this way, the number that is by itself, in this case this 2, I'm going to go 2 times 25x and also 2 times 6. So that's going to give me 50x minus 12 equals, now on the other side, 26 times 13, let me go this way, 26 times 13 is equal to 338. Okay, to get the 50x by itself, this minus 12. Let me go here as a plus 12. Don't forget to switch the sign. So then I have that 50x. Now 338 plus 12 is 350. Let me divide both sides by 50 to get the x by itself. 350 divided by 50 is 7. Again, I simplify at the beginning because I didn't want to deal with big numbers. Now, if you're not afraid of big numbers because you have a calculator, go ahead. Keep the big numbers. You don't have to simplify. Now, let's take a look at number 58. So we're solving for x here. I'm going to say, okay, so 4x plus 14. Okay, now 4x plus 14 goes either with 66 or 121. Okay, so if 4x plus 14 is the bigger side, right, looking at the small triangle, I have two sides, 4x plus 14 and 36. The big side of the small triangle goes with the big side of the big triangle, and the small side goes with the small side. If you can tell that 4x plus 14 is bigger or smaller than 36, then you know if it goes with 66 or 121. I'm going to say 4x plus 14 looks like the big side, so 4x plus 14 goes with 121. That's what it seems like. If I want to make sure, I know 4x plus 14 is the side SA, right? This is the side, look on the side, the letter S with A. So that's the first two letters from this triangle. So that's going to go with the side AB, which is 121. Okay, so I was correct. And then I'm going to say 36 goes with 66. So let me write my fractions. 4x plus 14 over 36. Notice I use the two measurements that I circled. And I know 4x plus 14 goes with 121. And 36 goes with 66. Okay, now I want to simplify a little. I don't want to deal with big numbers. So 121 over 66, let me divide each by 11. So that's going to give me 11 over 6. So I divided each by 11. If I want to simplify more, I could. But I think the numbers are not that big anymore. So I'm just going to cross multiply now. This way, I'm going to multiply the 6 times 4x and 6 times 14. So that's going to give me 24x, right? 6 times 4x, 24, plus 14 times 6 is 84 equals 36 times 11 is 396. Okay. Now this plus 84, I'm going to move it to the other side as a minus 84. Don't forget to switch the sign. So that's going to give me that 24x equals 312. Now let me divide both sides by 24. X equals 312 divided by 24 happens to be 13. All right, so X is equal to 13. Now let's take a look at number 59. In case I have it here, the polygons in each pair are similar. Find the scale factor of the smaller figure to the larger figure. Okay, so the smaller figure comes first. Okay, there's a few ways how we can write fraction or scale factors. I'm gonna talk about them right now. So I'm gonna use this 7 from the small figure, which is corresponding with 14. Okay. Now to begin with, there's 3 ways how we can write scale factors. We can write it as a fraction. I'm gonna use the small figure first. Notice the order how the instructions come. Find the scale factor of the smaller figure to the larger figure. So the first word that I see, or the first phrase that I see, smaller figure. So the smaller number comes first. Okay, so I can write this as a fraction, 7 over 14. I can write it using words, 7 to 14. Or I can use it writing a colon, 7 colon 14. Now, from these 3 ways, you're going to see it in the real world. You're going to see it all 3 ways, especially if you go to the store and look for those cars that you build, the model cars. They usually use fractions, okay? But you can see it. They also use the colon method. Now, our case, we're going to use the colon method. So let me start by writing 7 colon 14, okay? Let me start using that. So we're going to use the colon method, 7 to 14. Now, if you can simplify your numbers, do so. 7 and 14, I can divide each by 7. So I'm going to divide each by 7. So they're going to reduce to 1 and 2. 1 to 2. That's going to be my answer. No spaces. It's all together. 1 to 2. Now, you guys might be wondering, do I have to use the 7 and the 14? What if I wanted to use the 5 with the 10? Go for it. You get the same answer anyways. Okay, so let's take a look at number 60. Solve for x. The polygons in each pair are similar. Then I have a figure that says B, another figure that says A, and then it says scale factor from A to B is 5 to 6. Okay. Notice how I'm seeing it using the words A to B, and I see it using the colon. To work on this, I'm going to write it as fractions. All right, so the measurements that I have, A to B, right? Because that's how this thing says, A to B. So the information from A comes first. Let me write this as a fraction. Let me write this as 15 over x plus 8. It's not that I'm going to go with the smaller figure always, because A could be bigger. It just says A to B. So make sure you write the information from A first. So 15 over x plus 8 is equal to, my scale factor here says 5 to 6. So I'm going to write this as 5 over 6. Now to solve for x, let me just cross multiply it this way. 5 times x plus 5 times 8. So I have 5x plus 40 equals 15 times 6, which is 90. Now, to get the 5x by itself, this plus 40, let me go as a minus 40. Don't forget to switch the side. So I have that 5x is equal to 50, right? 90 minus 40 gave me 50. Now let me divide both sides by 5. So I'm going to get that x is equal to 10. Okay, solve for x, 10. Found the value of x. Let's take a look at number 61. We have 8 more questions. So let's see, 61. When we have parallel lines, right? We started seeing those this week. When we have parallel lines, I'm going to see this as two different sides. There is one side here and there's another side here. I'm going to see this as two different sides. I'm going to focus on the side that is all numerical. There's two numbers, 3 and 5, but I can get a third number, right? 3 and 5 are small measurements, so I'm going to find out how much is the whole thing, and I'm going to say this whole thing is 8, right? 3 and 5 combined gives me 8. Okay, now let me solve for the indicated measurement. That question mark, let me change it for x. Again, we learned back in Algebra 1 that when we don't know the value of something, we replace it with the letter, and it's usually x. So I'm going to say x. I'm going to use x and 16. So let me write my fraction. X over 16 equals. Now x goes with 5. And 16, because it's the whole thing, 16 goes with 8. Now let me cross multiply 8 times x, 5 times 16. Let me divide both sides by 8. So x is equal to 10. Okay, not bad. Let's take a look at question number 62. Focus on the side that it's all numerical. And I'm going to say this little side right here is 9. Remember, if I add the two small sides, 9 plus 6 is equal to the big side. So 9 plus 6 equals to 15. So I know that it's 9. I might use it, I might not, but I'm going to have it just in case. So let me call this question mark, let me call it x. And from the side that has the x, I'm going to use the values x and 25. Now x goes with 9. 25 is the whole thing, so 25 goes with 15. Okay, so now let me cross multiply. 15 times x, it's 15x. 25 times 9, 225. Now to get the x by itself, let me divide both sides by 15, so I get the x by itself. 225 divided by 15 is 15. Another thing that we saw this week was the angle bisector rule. Okay. You guys see my angle on the top is cut in half. Okay. Now the side, and let's go with blue here. The side that is all here, I should have 3 values there. Okay. Two small figures and two small numbers and a big number. I'm going to say this other small number here is 6. Because those two combined, the 3 and the 6 combined, have to equal to 9. That's why I knew that was 6. Okay, so now let's see. I'm going to change the question mark for an x. From this triangle, I'm going to use x over 3. X goes with 8 and 3 goes with 6. Okay, let me cross multiply. 6 times x equals 8 times 3. So I have the 6x equals 24. To get the x by itself, let me divide by 6. X equals 4. I know the instructions to begin with said find the missing length indicated. I called it X, so I have X equals 4. So just 4, right? Just 4 will be my answer. Looking at question number 64, I'm gonna say this whole thing, right? The question mark, let me call it X, and I'm gonna say this whole thing is X plus 8. I added the two measurements. I might need the X plus 8, I might not need it, but I'm gonna have it there just in case. All right, so from one triangle, I'm gonna use the values X and 27. X goes with 8 and 27 goes with 12. So X goes with 8 and 27 goes with 12. Before I cross multiplied 8 over 12, let me divide each by 4. So let me just call this 2 over 3. Just want to deal with smaller numbers if possible. Don't have to, right? We can use a calculator, deal with big numbers, but I simplify just to deal with smaller numbers. When I cross multiplied, 3 times X equals 2 times 27. So I have 3x equals 20, equals 54. So let me divide by 3. So to get the x by itself, so we're going to get that x equals 18. Right? 54 divided by 3 was 18. You don't have to simplify your fraction to begin with, right? The 8 over 12. You could have done 12 times x and 8 times 27. You want to try it at home, and you're going to see that you don't have to. You're going to get the same answer. You're just going to deal with bigger numbers. All right, now here, find the indicated length. There's a flagpole that's 4 meters tall that casts a cast a 6-meter shadow. Okay, so let me draw this as the best that I can. So there's the flagpole standing up, and it's 4 meters tall. The shadow's right here on the floor, and it's 6 meters tall. 6 meters long. At the same time, a nearby building, so there's a building, cast a 24-meter shadow. So the shadow's right here on the floor, 24. I don't know how tall is the building, so let me call it X. How tall in meters is the building? Round your answer to the nearest tenth if necessary. Okay. So I create this so they look like triangles. I'm gonna just, from one triangle, I'm gonna use the fraction x over 24. I know x goes with 4 and 24 goes with 6. I'm going to cross multiply, solve for x, but keep in mind that here it says round your answer to the nearest tenth if necessary. That means I might have decimals. Now, tenth, think about it. Tenth sounds like the number 10, right? How many zeros are in 10? Well, 1 0. So tenth means 1 decimal place. If I ask you to round it to the nearest hundredth, that would mean 2 decimal places. Okay, so I might have a decimal. That's why it says if necessary. All right, so I'm going to cross multiplied. Change this back to blue. So 6 times x equals 24 times 4. Now to get the x by itself, let me divide both sides by 6. X equals 16. Okay, don't have a decimal. I said I might have a decimal, might not. Okay, now the one that was giving you a little bit of hard time here is a person 5 feet 8 inches casted 3 feet 4 inches shadow. At the same time of day, a nearby building cast a 16 feet 6 inches shadow. How tall in feet and inches is the building? Round your answer to the nearest inch. The first thing I'm going to do is I'm going to change everything to inches. Or actually, let me draw this first, right? So there's a person that has a shadow. And there's the building. I don't know the height of the building, right? And then there's the shadow. I'm gonna change everything to just inches. So the person was 5 feet 8 inches. I know there's 12 inches in a foot. So 5 feet will be 60 inches, right? 5 times 12. Just 5 feet is 60 inches. Now 5 feet 8 inches, I'm gonna say this person is 68 inches tall. Right? I move everything to inches. The shadow is 3 feet 12 inches. I know 3 times 12 is 36, plus the 4 more inches. I'm gonna say the shadow is 40 inches. Now the building, right? The shadow of the person was 3 feet 4 inches. Then the building has a shadow of 16 feet 6 inches. I know 16 times 12 is 192, plus the 6 more inches. I'm going to say the shadow is 198 inches. So first of all, I change everything to inches. All right, let me solve for x. I'm going to say x over 198 is equal to 68 over 40. I'm just going to cross multiply. Let me go here. So I have 40x equals 198 times 68 is 13,464. Then I divide both sides by 40, and I'm going to get that x is equal to 337 inches. One thing here, my calculator really gave me 336.6. I rounded to the nearest whole inch, right? The answer says round your answer to the nearest inch if necessary. So, okay, so I rounded this to 337 inches. Okay, so far I know 337 inches. This is the easy part. Now the hard part is I have to change this 337. I have to change this to feet and inches. All right, let me divide 337. Let me divide it by 12. Let me divide this by 12. And my calculator gives me 28 point, and then there's some decimals. Okay, so far I know part of my answer. This thing is 28 feet. And then some inches, right? But at least the feet part, I know 28 feet. Okay, now let me use my calculator. So I know 28 feet. That's part of my answer. 28 feet. Now, I know 28 times 12 is 336. Okay, so 28 times 12, let me write that again. 28 times 12 is 336. But this thing, it's supposed to be 337. All right, how many more inches do we need? Well, 1 inch, right? So the building is 28 feet, 1 inch. So this will be it. 28 feet, 1 inch. Notice how I wrote the feet in inches. That's the key that you guys have next to the enter sign. Okay. Now, some of you might be wondering, Mr. Leonzo, why do we have to do this? Why don't we have it as a decimal like number 65? Now, this is the reason why. Here in the US and England, we use feet and inches. The rest of the world uses meters. Now, if you're going to go to a place that uses meters, do it in decimals, kind of like number 65. Now, here in the US and England, you guys want to find out the height the way we speak, then you have to do it in feet and inches. Because we're here in the US and we say feet and inches. Now, that's how we're going to measure it. So we can tell, right? I usually don't tell people, my height is 66 inches. No, we actually change it to feet and inches, right? So That's the reason why. Okay, now let's review the last two questions. We call this similar right triangles. And I said in this figure, there's three triangles. There's three triangles, and I only need two of them. So let me just draw two right triangles here. Now, this side right here, I'm going to call this 9 plus x, right? Because one small side is 9, the other side is x. Combined, it's 9 plus x. I cannot simplify it, so I'm just going to call it 9 plus x. All right. So again, there's three triangles. Let me highlight all three triangles. There's one right triangle here. You guys see it. There's another triangle here, right? You guys see it. And the third triangle is right here. Okay, you guys see it. Okay. Now, from those three triangles, I'm only going to use two. Now, how am I going to choose which two? Make sure you know two measurements for each triangle that you choose. So if I look at this small triangle, the 90-degree angles are this corner. I know one side is 9, the other side is 15. I want to rotate it so it matches that. Okay, so I see the small side is 9 and the hypotenuse is 15. So I'll just leave it at that, 9, 15. Okay. Now the other triangle, well, let me show another triangle. I might use it, I might not. For this measurement, I only know x. But the other two sides, let me put question mark, I don't know, right? I only know one side is x, but I have no idea. I have no information about the other two sides. So I cannot use that triangle. Instead, I'm going to use this big triangle. I know one side is 15, right? The small side is 15, and I know the hypotenuse is 9 plus x. So this is 15, and this is 9 plus x. So I'm just going to create my fractions. Using the information from the triangle at the bottom, I'm going to say 9 plus x over 15 equals, now using the corresponding sides, 15 over 9. And I'm going to cross multiplied 9 times 9 and 9 times x. I'm going to have that 81 plus 9x equals 15 times 15 is 225. The rest is just algebra, right? To get the 9x by itself, let me move the 81 over. Instead of positive 81, let me move it as a minus 81. Don't forget to switch the sign. So I get the 9x is equal to 144. Right, 225 minus 81 gave me 144. Now to get the x by itself, let me divide by 9. 144 divided by 9 is 16. All right, so x equals 16. Not bad. Let's take a look at number 68. In case I need this, big side is 36 plus x. And I'm going to use two triangles. There's one and there's two, right? Two right triangles. First triangle I'm going to use will be this one. I know one side is 36, the other side is 60. I know my 90-degree angles right there. I have to match it there. So I'm going to say this is 36 and this is 60. You got to rotate, flip, whatever you got to do to make that fit. The other triangle I'm going to use is this one. I see the small side is 60. The hypotenuse is 36 plus x. So this is 60, and this is 36 plus x. Based on the triangle at the bottom, I'm going to have 36 plus x over 60. Like I said, I use the measurements from the triangle at the bottom. And then based on the corresponding sides, I'm going to say 60 over 36. I'm going to simplify a little. 60 over 36. Let me divide each by 12. So I have 5 over 3. Right? I divided each by 12. So I'm just going to make my numbers smaller. Okay. Now this way. Had to multiply the 3. 3 times 36. And then 3 times x. So that's going to give me 108 plus 3x. So remember, I went 3 times 36 and then 3 times x. And then this other way, 60 times 5 is 300. Okay, to get the 3x by itself, the 108, I'm going to get rid of the 108, move it to the other side as a minus 108. Don't forget to switch the side. So that gives me that 3x is equal to 192. Right, 300 minus 108 is 192. Now to get the x by itself, let me divide both sides by 3. So x equals 64. Beautiful. Let me zoom out so that way you guys can see what we did. You should be ready for the test tomorrow.